Hi guys! For this video lesson, we're going to discuss truth values of propositions under your General Mathematics from Quarter 2, Module 16. I'm your subject teacher, Arvin Enriquez. Our lesson objectives: at the end of this video lesson, you are expected to construct truth tables of propositions. Second, determine the truth values of proposition. And lastly, distinguish the proposition as tautology or contradiction. Let's now move forward with the truth values of propositions. Aside from performing operations on propositions, determining their truth values is also possible. Yes, it is very important for us that we know how to deal with your truth table, so we can easily visualize what will be the truth values of these propositions. So given some truth values of its component propositions, the truth value of a compound proposition may be known. Yes, it is, no? We can easily determine the truth values of a compound proposition by simply dealing with your truth table, wherein we can put the truth value of each of the propositions involved. Once we apply, right after applying your logical connectors, your conjunction, disjunction, negation, conditional, and by conditional, we can easily determine or identify, what will be the truth value of the resulting proposition once we combine two or more propositions. So the truth table will systematically guide you to determine the truth value of a compound proposition. Yes, no? By simply using your truth table, by simply putting all the truth values for your propositions involved, we can actually come up with a appropriate and right conclusion for what is the truth value of this compound proposition. So in the first place, logical operators may be defined by using truth tables. Yes, it is, no? But we really need to follow the uh, dominant level of these logical operators, or the dominant order, I mean, from strongest to the weakest. There are times wherein there is no parenthesis in your given. If you're asked, for example, to convert a certain symbol to in words or in verbal sentence, then we must follow, or we must know how to follow the dominant order from strongest to weakest for these logical connectors or connectives. So again, the strongest is your biconditional. The second is strongest, and that will be your conditional. And with the same level or equal value, that will be your disjunction and conjunction. And for the weakest connectives that we can use, no, is your negation. So that's how we follow the dominant order of these logical connectors. For us to come up with a right truth value, once we are asked to combine two or more propositions dealing with these logical connectors or connectives. So truth values of compound propositions will be built on this. Yes, it is, no? because with the use, again, with the use of your truth table, we can easily visualize because it is a systematically guide for us. So each of the truth values for each of the proposition will be provided by this table. So if we're asked to combine these propositions using your logical connectors, we can just simply go by step, and we follow the dominant order of these logical connector or connectives from strongest to weakest. Now let's deal with this what's in activity. So we're asked to complete the following truth tables of logical operators. So we learned this one in your last module from your module 15 on how we deal with this truth tables and how we apply your logical operators with the given truth values of a certain propositions. Now in this case, for number one, there is a negation here. We all know that negation is totally opposite of what the truth value of this original proposition P. So you just simply take the opposite truth value of this one for you to get the negation of your P. So here for number two, it's about conjunction, as you can see this one. So it's about conjunction. For number three, it's all about disjunction. And for number four, it's all about your conditional. And five, it's about your biconditional. So this activity is just like a review for us, no, to recall the concept of your logical operators that we apply, your conjunction, disjunction, negation, conditional, and biconditional, wherein with the use of this truth table, we can easily visualize because this is a systematical method that we can use, no, for us to be easily visualize what will be the truth table if we're asked to combine two or more given propositions, and there's an involvement of these logical operators. So in this case, it's up to you if you're going to answer this what's in activity, but entirely this activity is just like a review on how we apply your logical operators at the same time dealing with your truth table. Now, take note that the knowledge of truth tables of logical operators is very important to be successful in this module. Yes, it is, no? As a learner, you should be familiar with the truth value of each logical connectors. So, you need to be familiar, no? With the concept that this conjunction, disjunction, negation, conditional, and biconditional brought to us on how we deal with the truth value or the resulting truth value when we are using these logical operators or connectors or connectives once we're asked to combine two or more propositions. Now let's deal with the what's new. So hey there, so before you continue reading a new lesson, pause for a while, have a seat, take a deep breath. Now read the poem word for word silently. So Truth That Values Most by Azalea A. Galliano. So life can teach us good and bad, while others feel the heat before they see the light. As for some, a word is enough, and they make it a guide. Even if keeps the entire law, but disobeys one commandment, that person shall be charged guilty, and shall be considered unworthy. Life can best be spent on service. No one can serve two at the same time. However, you will satisfy and be satisfied with an endeavor you are in, but the other will surely be forsaken. While opportunity lies on your doorsteps, study well. Not all have this opportunity to pandle. Others give up, yet some chase for their dreams, but you have no reason to surrender. Take time to ponder. However, above all, the main purpose of life is service to the Creator. We fulfill our mission if and only if we serve Him. No more, no less. It is everybody's calling. I guess you're done contemplating the message of the poem. Today or later, you will understand the lines on and in it. In the meantime, can you spot which stanzas deal with concept of logical operators? Your negation, conjunction, conditional, and biconditional. So with the use of and, or, not, but, if then, and if and only if, those are phrases that we can consider that represents your negation, conjunction, disjunction, conditional, and biconditional. So if you internalize the poem, you will identify and understand the differences of these logical operators. You will be able to discover concepts behind each of them. So with the concept of these logical operators, we are now dealing with the truth values of a proposition. And that topic will be discussed on this module. Now let's deal with this. What is it? So your truth value and the truth table defined. Every proposition has two possible truth values. It can be true or false. That's how we define your proposition. It is a declarative sentence or a statement that can be true or false, but not at the same time that your statement can be true and false. That is, the truth value of a proposition, be it simple or compound, is either true or false. Regardless whether the given is a simple or compound proposition, the thing is that the truth value will be dependent if the statement or the declarative sentence or a proposition is true or false. If that is a true statement, the truth value is true. If that is a false statement, the truth value is false. So that's how we define your proposition. The truth value, therefore, refers to the truthfulness of a proposition that may either be true or false. This can be represented in tabular form. So that's why we use your truth table. So the table that shows the complete possible truth values of a proposition is called the truth table. So these are the good examples of a truth table wherein we can easily visualize the truth values of each of the given propositions here. There's a P and Q. And at some point, your P is your hypothesis, your Q is your conclusion. No? With the use of logical connectors, you can easily identify or determine what will be the truth value of the combined propositions. With the help of this truth table, it is easy for us to visualize what will be the truth value of the resulting proposition. Now, if proposition P has the following truth table. Now, your proposition P can be true and or false. So there are times that your proposition is false, there are times that your proposition is true, but not at the same time that they are true and false. Suppose we are given two propositions P and Q. Since there are four possible combinations of the truth value, these are the possible combination. It can be true, that both your P and Q are true statements. It can be true and false. One can be false and one can be true. It's the same thing with the third one. It can be false, true. And the last combination can be false and false. So both your P and Q propositions are false statement. Or the truth value of this P proposition and Q proposition are false. Then their truth table is. So we simply use this truth table for us to, it serves as a guide, no? Your truth table will serve as a guide for us to visualize. We can easily visualize, no? What will be the true value of once we are asked to combine two or more propositions using your logical connectors. So that's how we deal with your truth value and your truth table here in this module. So basically this uh, module is all about the truth value. At the same time, we use your truth table for us to easily determine what will be the truth value of the combined propositions from a simple. Using your logical connectors, we combine two or more simple propositions to make it compound proposition. And now, what will be the truth value for this combined proposition? So it follows, therefore, that if there are three propositions P, Q, and R, for example, their truth table is, so we assume to be like this, no, on how what are the possible combinations that we can get from these two propositions. And your R, as you can see, these are the three possible combinations that we start from, wherein that these three propositions are true. The truth values of these three propositions start to a triple T here. That means that each of the proposition given to us, the your PQR, have the truth value which is true, as you can see. And we end up with the idea that these three propositions are false statement. That's why their truth value are false. So how many possible combinations of truth values do we have if there are three propositions? So we are now asked, no, how many possible combinations of truth values we can get from a three propositions? Can you name them? Notice that the number of truth value combinations increases geometrically as the number of propositions increase. Yes, it is. That is, there are 21 if there are 2, 22 is equal to 4, 23 is equal to 8, and 24 is equal to 16. Such combinations, if there are 1, 2, 3, 4, and 4 propositions respectively. How many truth value combinations shall we expect if there are n propositions? So basically, in the previous module, the truth value of a logical operators was introduced, but on this module, you will gain a deeper understanding of each truth value. Because entirely, this module is all about the truth value of a proposition. So we're going to answer these questions on our next slide. Now, for example number 1, suppose P and Q are both false propositions, and R is a true proposition. Determine the truth value of your P conjunction negation Q conjunction P conjunction Q. As you can see here, show its truth table. So for our solution, since P is a false, then its conjunction with another conjunct is false. Yes, it is. The conjunct P uh, negation Q is being false makes the whole conjunction P conjunction negation Q conjunction P conjunction Q is false. So the truth table for this P conjunction negation Q conjunction P conjunction Q is as follows. As you can see, we will prioritize what's inside the parentheses. So after uh, converting this two proposition inside your parentheses into one resulting proposition, then we we are now moving forward with the idea that we're going to combine this resulting proposition from inside, no, what's inside your parentheses, then we apply the logical operator or connectives outside the parentheses. And that will be the final resulting proposition that we can get, no, from this example number 1. Now, know your priority first. As you can see, there's a given value for your P proposition and Q proposition here. And what value are you needing? So first thing to do is to look for the value of your negation Q. Because before we come up with the idea that we're going to combine this P conjunction negation Q, first we need to get the truth value of this negation Q. That's why on the third column here, we just simply get the truth values of this Q proposition. So again, your negation is just like totally opposite of your original proposition. So if this is true in your original proposition, your negation Q now is false. If that is false, your negation proposition is true. Same thing with the last two here. If your original proposition is true, then your negation proposition is false. Same thing with the last, though. If the original proposition is false, then the negation of this proposition is true. That's why this is the value that we can use in determining what's inside these parentheses. What will be the resulting value in the first parenthesis, no? That we can get, no? Once we combine the negation Q to your P proposition, no? In this one. So what's involved here? That will be this one and this one. For this fourth column here in your table, our values are concerned here is your original proposition for P and your negation Q. So what will be the value of this one? So apply your conjunction. If one of your proposition is false, no, then our resulting value now, since your P proposition is true, then your negation proposition Q here is false. So one of your proposition now involved in this column number 4 is false, and automatic that your resulting proposition now is a false statement. That's why it is false. Now, if they are both true, as you can see here, your P proposition in your third row, that is true, and for your negation Q, the same thing with your P proposition, this is also true. Then your P, or the P conjunction negation Q, now is also true. Again, once we apply the concept of your conjunction, so if both your propositions involved in this one are true, the truth value of these two propositions are true, then once we apply your conjunction, still the truth value is true. It's the same thing, no, with the false. If both truth value of these two propositions are false, then the resulting value for this one, for your conjunction, is also false. Now, if one of them is a false statement and the other one is a true statement, then the resulting proposition now, apply your conjunction, is false. So the truth value of this conjunction is false. When one of your proposition, or when one of your truth value of these two propositions involved is false. Now, going to your P column here, no, as you can see in this one, we can now proceed with this P conjunction Q. We're now using the original proposition P and Q, so there's no involvement of negation. So it's the same thing on how we apply your conjunction. If both your proposition P P and Q are true, then your P conjunction Q now is a true statement. Now, if one of them, if one of them is a false statement, since Q now here, as you can see, in this case, no, if Q proposition is a false statement, then, or vice versa, if P, is a false statement, or Q is a false statement, still, your P conjunction Q is a false statement, even if there is a true, or one of these two proposition is a true statement. Now, if they are both false, represent a false statement, no, then your P conjunction Q is a false statement also. So that's how we assess. Now, dealing with the last column here, so we're going to use our truth values from your fourth column and your fifth column here, and we're going to again the concept of your conjunction. A while ago, I said if one of your proposition is a false statement, then your resulting value is a false statement. If one, again, for the next row, still one of your proposition is a false statement because the resulting value for that P conjunction Q is a false. So now false now, then for your sixth column now, still false up to the last, no? Since the from your fourth and fifth column, they are both false statement for the last possible values of this one. So therefore, all the values or truth values for your last for the last column will be false. If you're asked to find the value or the truth value of this P conjunction negation Q conjunction P conjunction Q, then the truth values for your last column are all false. So moreover, notice that the proposition P conjunction negation Q conjunction P conjunction Q is always false. Yes, it is, no? Based on the truth table that we use, that all possible truth values that we can get, or we arrive, no, with the conclusion that all possible truth values, once we apply these logical operators that we use on these P and Q propositions with this kind of scenario, is always false. Such a proposition is called contradiction. That's why we define your contradiction now as a logical incompatibility, no, between two or more statements or propositions. Again, your contradiction is a logical incompatibility between two or more statements or propositions. Meaning to say, when your proposition is always a false statement, then that proposition is called a contradiction. So it occurs when those statements or propositions taken together yield a falsehood. That's how we use this contradiction. So by extension, outside of logic, contradictions are also said to occur between actions for which the motives are held to be contradictory, or between beliefs or principles when their content is contradictory. Meaning to say, once a proposition is always a false statement, that proposition is called contradiction. Other resources call it fallacy. So it is denoted by this kind of symbols, just like an angle or something in geometry. So, but we use this symbol for us to represent your contradiction or fallacy. So for example number 2, so given the statement, a diabetic either takes conventional drugs, natural medicine, or both, determine the truth value of P disjunction negation Q conjunction R in each scenario. So let P, a diabetic, takes conventional drugs, let Q proposition a diabetic takes natural medicine, and your proposition R, a diabetic takes both conventional and natural medicines. So for your scenario A, patient A only eats leaves of her insulin plant to control his sugar level. For scenario B, patient B consults his conventional doctor and buys diligently the prescribed conventional drugs. For scenario C, patient C supplements conventional drugs with natural medicine he reads is effective as well for diabetic. So for scenario A, patient A is for the natural plants. Scenario B for the prescribed conventional drugs. So scenario C, it's the combination of the natural medicine and the prescribed conventional drugs. So for the solution, scenario A, the negation states that a diabetic does not take natural medicine, which is false in scenario A. So each conjunction with proposition R, which is also is false as we've learned. On the other hand, your P is a false since patient A takes natural medicine only. Yes, it is, no, for scenario A. So the disjunction of a false proposition and another false disjunction is false. Yes, it is, no. It will be dependent on that. Its truth table is illustrated as follow. Again, if your P proposition in original is a false statement, and in your Q proposition, if the truth value is true, then your R is a false statement or your truth value is false, we just simply get the negation of that Q, meaning to say what is totally opposite of what your original proposition Q. If your original proposition is true, then your negation proposition Q now is a false statement, or the truth value is false. Now, we're now asked to get the negation Q conjunction R. So we just simply use this one to this column and this R. They are both false statement. Meaning say once we apply your conjunction to two propositions involved where the truth value are false, then it's automatic that the conjunction of these two propositions is automatically false. Now, when we apply now the disjunction between your P proposition which is also false and another false proposition, then the resulting value is still false, even if we apply your disjunction. Why? Because if both your proposition are false statement or the truth value of these two propositions are false, then the disjunction of these two propositions is automatically false. That's why our resulting value here in your last column in your first table is false. Now, for your scenario B, since negation Q is true in this scenario and R is false, then their conjunction is false. Yes, it is. And since P is true and your negation Q conjunction R is false, as we have said, then their disjunction is true. Simply put, since the proposition involves disjunction and one disjunction P is true. So without further analysis, we may conclude that the disjunction is true. Why? Because there is an involvement here that your proposition P now is true. No? In your disjunction, if one of your proposition is a true statement or the truth value of one of your proposition involved is true, then the resulting value or the truth value for the disjunction of these two propositions is automatically true. That is because disjunction can only be false if both disjunction is false. its truth value is illustrated as follows. So as you can see on this one, no, in this table, your P proposition is true, your original P proposition is true, your original proposition Q is F, then your original proposition R is also F or false. Then once we're asked to get the negation of your Q proposition, that is automatically opposite of your Q proposition, which is false, and that's why it is true here for your negation Q. Once we are asked to get the negation conjunction R, so both are false statement in this case from your original. I mean, your negation Q is a true statement, no? Because it is totally opposite of that Q proposition, which is false. Now, in your fifth column here, negation Q conjunction R, so our concern now is to combine your negation Q and your R proposition. When your negation Q is a true statement, then we are asked to combine it to an R, which is a false statement. So the conjunction of these two propositions involved is a false statement, or the truth value or the resulting truth value of these two propositions combined using your conjunction is a false. Is false, I mean. No. Now, in this case, if this is a false truth value, and now we're asked to combine this one to your true statement with your P proposition, and using the concept of your disjunction, then one of your propositions involved now is a true statement. That's why if we apply this one, this disjunction as your logical connector in your last column here, your truth value is false. Why? Because one of your proposition is true. Because your original proposition P is the truth value of this P proposition is true. While your negation Q conjunction R is false, even if that is false, then one of them is true. Since P proposition is true, then the disjunction of these two propositions is only, the resulting truth value of these two proposition, or the disjunction of these two proposition, is also true. At least one of them, or at least one of the propositions involved is true. Then the disjunction of these two propositions is automatically true. That's why it is true. So for scenario C, so both negation Q and R are true because patient C is not taking conventional drugs only, because it's a combination of your conventional drugs and natural medicine, but instead he takes both conventional and natural medicines. Thus, the conjunction of these two propositions is true. Then, although P is a false statement, but since one of the disjuncts is true, then the disjunction P, disjunction negation Q conjunction R is true because one of your proposition involved is true. Once we apply your disjunction, its truth table is illustrated as follows. Again, if your P and Q are false statement, or the truth value of your P and Q propositions are false, then your R proposition is true. Then the negation of Q is totally opposite of this one. That's why your negation Q now is true. Then the conjunction of negation Q and R, so this will be the involvement of this one. So if one of these, in this case, no, negation Q conjunction R, so that will be a true statement. Now, if your P conjunction in this last statement, no, so there's an involvement of your original P proposition, as you can see here, and your negation Q conjunction R in this case. So we just simply combine these two for this one. So one of your proposition involved is a true statement. That's why if for us to get the disjunction of P and your negation conjunction R, then the value of this one, or the truth value for this one, is true. So that's simple it is once we are dealing with your truth table, because we can easily visualize what will be the resulting truth value if we're asked to combine two or more propositions involved on this case. So for example number 3, let P and Q be propositions. So any letter can be a proposition. It's up to you what letter are you going to use, but in this example, most of our example, our proposition will be P and Q. So determine the truth value of your P conditional Q, conditional negation P, disjunction Q. So construct its truth table. So for the solution, since there are two propositions P and Q, thus, the truth table will contain 4 rows, the first 2 columns of which are, so these are the possible combinations that we can get for the truth value of these two propositions P and Q. So first thing is they are both true. Then second thing, that your first proposition P now is true, then your second is false. And the other is that your first proposition P is a false statement, then your Q now is a true statement. And for the last combination that we can get from the truth value of these two propositions are both false. So these are 4 combinations that we can get from these two propositions involved in this example number 3. So using the truth table for the definition of the conditional, negation, and disjunction statements that your P, the conditional P and Q, and the negation P, P, uh, disjunction Q, respectively. So you need to add 3 more columns to indicate the truth value of each statement. So as you can see, there is a given truth values for this P, conditional Q, negation P, and disjunction Q. So we just simply put this one, or we just simply connect these 3 columns to the first table that we presented a while ago. So lastly, you need to consider that the truth value of the proposition. So in this case, our concern now in this one is this 4 true statements here, or 4 truth value that are true, no, based on the resulting, or uh, right after we use the logical connectors being involved in this example, no, why these 4 are true statement or true proposition at the end of this story. So in this case, no, once we apply your conditional, so the involvement of this one, this will be our concern, no, for this last column here. So if they are both true, no, for a conditional logical connectors, if both your two proposition involves are true statement, then applying the conditional of these two propositions, then it is true. It's the same thing when they are both false, then the resulting value is true. Same thing with the last two, since these are true statements. Same thing with this column, they are both true statements, then the resulting value for these two last row in this table is also true. That's why if we use the conditional as your logical operators here, no, if both your two propositions both are true, or even if they are both false, still the resulting value, it can be true, no? There's no other option, but it's only true that the resulting value, or the truth value of the resulting proposition, will be always true. So notice that the proposition here, no, is always true. Yes, it is, no, based on the table. Such is called tautology and is denoted by R, or as you can see, it's small sigma, no, in a Greek letter. It is the opposite of contradiction, because contradiction is a proposition that is always false. Now, tautology now is the proposition that is always true. So in mathematical logic, A tautology is a formula. We can say that this is a formula or assertion that is true in every possible interpretation. So there is no way that a tautology is a false statement. It is a proposition that is always true. No? So for example, y x is equal to y or x is not equal to y. Similarly, either the ball is green or the ball is not green is always true, regardless of the color of the ball. Yes, it is no. The truth value that we can get from this tautology, the resulting proposition, if we're asked to get the truth value of these resulting propositions, then your tautology is always true. So for example number 4, let P and Q be propositions. Determine the truth values of your P conjunction negation Q, conjunction P conjunction Q. Construct its truth table. So there are two propositions involved, your P and Q. So these are the following combinations that we can get from these two propositions. So we simply use these values. So thus the truth table will contain 4 rows, the first 2 columns of which are, as you can see in this one. So we're going to add this second table on this one. We're going to attach, no, for us to be easily visualized, no, using the truth table for the definition of the negation and conjunction statement. That negation P is totally opposite of what your proposition Q is. That's why it's totally opposite. If your original proposition Q is true, then your negation Q is false. So that's simple it is. Now, your P conjunction negation Q and your P disjunction conjunction Q, respectively, you need to add 3 more columns to indicate the truth values for each statement. That's why we come up with the idea of the second table here with your third, fourth, and fifth columns that we're going to attach for your first 2 columns. Now, in this case, applying the concept of your negation and your conjunction here with your two propositions involved, your P and Q, our resulting value here are all false. No, meaning say that the truth value for these 4 resulting propositions here are false. Meaning say this represent no your contradiction or fallacy. So we denote or we use this symbol no for us to represent your fallacy or contradiction. So again, that's how we deal with your contradiction and tautology. Again, your tautology is a proposition that is always true, while your contradiction or fallacy is a proposition that is always false. So that is the difference between your contradiction and tautology. So for your activity, you can write your answer in your Katleya notebook, and your deadline will be announced soon. So determine the truth value of each of the following propositions. Show the truth table of each as well. So there's a given truth value for each of the propositions involved in each of the number here, no? You just simply get the truth value of the resulting proposition with these propositions involved and the conditions being given to us in this 1 to 5 scenario, no? With the involvement of your logical connectors. In number 4 here, it is a biconditional, no? Your negation P conditional Q by conditional R, where P is the true and Q and R are both false. So it's a biconditional. Your symbol there is a biconditional. So it's a typographical error. So you need to put a biconditional there, no? So please make sure that you put your answer or answers and solutions in your Katleya notebook. So, thanks for watching. So please do like, comment, share, and subscribe.